Hi, I'm Justin Mahood. I'm a product manager on Cloud Run for Anthos.
And I'm Adam Kane. I'm an engineering manager on Cloud Run for Anthos.
And we're here today to show you how to build a scalable web application using Cloud Run for Anthos on GKE. So first, I'll give you an overview of Cloud Run for Anthos, which is the technology that's at the core of the sample that we want to show you today. Then we'll talk through some of the problems that you'll need to solve when standing up an enterprise web application in a Kubernetes environment. And then we'll walk through our sample architecture and talk about the different tools in the Anthos and GKE ecosystem that you'll use to deliver this kind of application. And then finally, I'll give you a short demo of how to deploy our sample directly into your GCP environment. So let's introduce you to the product that's at the core of this sample, Cloud Run for Anthos. When developing web applications, serverless patterns are very, very popular. And why is that? Well, there's the operational model. You don't have to worry about infrastructure. It's inherently scalable, and you pay for what you use. But for developers, it's really the programming model that's attractive. They also don't have to worry about the infrastructure management. And fundamentally, it's optimized for service-based architectures, like web applications. But at the same time, we've got Kubernetes, which is now the de facto platform for running containers in the enterprise, and the de facto enterprise operations platform in general. So what if we could have the benefits of a serverless development platform with all of the control and flexibility of Kubernetes? And that's exactly why we created Cloud Run for Anthos. You can also think of Cloud Run for Anthos as Kubernetes the easy way. Developers get that serverless experience where they can focus on their application and their application logic rather than worrying about the intricacies of Kubernetes deployments and all of the Kubernetes concepts that go along with it. So you could say that Cloud Run for Anthos gives you the best of both worlds. It gives you the best of serverless. You can run any standard Docker container. It has request-based auto-scaling. It's very fast and scales down to 0. Includes incremental rollouts and rollbacks, so you can do things like blue-green deployments and rollback from production. And it also has a whole suite of monitoring and logging tools that are built in for the developer out of the box. And at the same time, the operations team gets all the benefits of a Kubernetes environment. The flexibility and control that comes with GKE, integrated policy support, the ability to run your compute completely within a VPC, custom node types and customization of the underlying hardware, and the extensive toolset that the Kubernetes ecosystem provides. And I'd be remiss if I didn't mention that Cloud Run for Anthos is based on the Kane open source project. This is an open source project that was started by Google with contributions from over 80 companies. And really what this guarantees is that the workloads that you write and architect for Cloud Run for Anthos are portable between Kane environments in whichever cloud platform you ultimately end up choosing. So now let's talk about actually building and architecting a web application. So let's imagine for a moment. You're a developer in an e-commerce company. GKE and Kubernetes is the ops platform that your company has chosen and standardized on. And you're given a task with delivering a line of business web application for tracking your warehouse inventory on a pretty tight timeline. So it's Monday morning, you sit down with your cup of coffee, you sharpen your pencil, and you start sketching out the architecture that you're going to use. And this is sort of what's in your head to begin with. You know that it's going to run in GCP. You know that there's going to be a web application of some kind. And you know that it ultimately needs to run on both desktop, laptop, and mobile devices. But then you really start to break it down. You know you're going to need a front end. You're going to need a back end and a database to store your state. You start breaking it down some more, and some more requirements really start to come into view. Since your company is standardized on GKE, you're going to use Cloud Run for Anthos for your backend services, for all of the serverless benefits in the Kubernetes platform we talked about earlier. And also, you know you're going to need to access and modify data in a database in a secure fashion. So in addition to using Firestore as a database, you want to be able to use your Kubernetes service identities for this authentication. And you'd be remiss if you hadn't thought a little bit about how load balancing and your URLs were going to work. And you realize that because you want to serve your front end from a static storage bucket, but have your backend services running in Cloud Run for Anthos, you need the app to be on a single endpoint and subdomain for CORS reasons. And you need path-based routing between the front end served from GCS and your multiple backend services running on Cloud Run for Anthos. And also, your enterprise has a hardcore requirement that everything needs to be HTTPS out of the box, as it should be, and that your GKE cluster can't be connected to the internet. And finally, as the last requirements start to come into view, you realize that you need to make sure this web application is accessible only by employees. They absolutely have to authenticate. And they need to use your company's federated identity provider. Also, there's different role-based features for workers and managers of the warehouse. So you need to have role-based access and an authorization platform for each call that goes through. And you're going to use Istio for that. So after a couple of weeks of hard work of architecting and writing the application, you're ready to hand it off and start managing inventory in your warehouse using an application you designed to run on Cloud Run for Anthos. But you sort of thought to yourself, it'd sure be great if there was a blueprint for all of this. And it turns out that there is. The Cloud Run for Anthos reference web application. You can see the link. It's hosted up there on GitHub today. And it's an opinionated set of best practices aimed at demonstrating a reference architecture for building an enterprise-grade web application on GCP using Cloud Run for Anthos. So now I'm going to kick it over to my friend Adam, and he's going to take you through each of the components of the architecture that we talked about a little bit earlier and go into a deep dive about how we implement those and how you can implement them in your environment. Adam?
Thank you, Justin. As Justin mentioned, I'm going to walk you through a little bit of a deeper look at some of the decisions that we've made in implementing our reference web application. So we'll start with a quick overview of the reference architecture that we've used. The goal of our reference application is to simulate a line of business web application that's built around the Cloud Run for Anthos platform. The subject matter of our application in this case is inventory management, but this is mostly arbitrary. The goal of this application is to provide a reference for implementing common web application patterns using Cloud Run for Anthos in combination with other GCP services. In this case, we've implemented the application using Angular and Go, but the infrastructure patterns that we demonstrate here are not specific to these languages. So as a quick overview of the architecture, it's comprised of a front-end UI and multiple back-end stateless services. It's exposed through a Google Cloud load balancer, which provides a consolidated endpoint to our end user. The front-end UI is statically served from a GCS bucket, and our backend services are hosted using Cloud Run for Anthos. End user authentication and authorization of our backend API requests are handled by Istio in combination with the Google Identity Platform. And our application state is stored in a Firestore database. Let's now take a look in a little bit more detail about each of the three major infrastructure patterns that we've used in our reference application. First, we'll talk about the database that stores state for our application. Of course, our backend services need to be able to access and modify the data in this database in a secure fashion. Ideally, we should be able to access this database using the service identities for our backend services and not have to manage explicit secrets or other authentication tokens. We use Firestore in this case, which is compatible with GCP IAM authentication, but this discussion is really relevant to any database or service which provides authentication using IAM. Our backend services, because they're running on Cloud Run for Anthos, are bound to Kubernetes service accounts, or KSAs. We use a feature of GKE called workload identities to bind these Kubernetes service accounts to Google service accounts, or GSAs, in IAM. Once this binding is in place, we can apply our access permissions for our database to the Google service accounts, and through workload identity, these permissions apply transitively to our Kubernetes service accounts. Once we've enabled workload identities on our Cloud Run for Anthos cluster, binding service accounts is a two-step process that requires action in both GKE and IAM. In GKE, each Kubernetes service account is annotated with the GCP service account annotation, which specifies the Google service account that we are binding the Kubernetes service account to. In IAM, a policy binding is created against the Google service account, and this policy binding specifies the Kubernetes service account and the namespace that that Google service account will be bound to. If you're paying close attention here, you'll notice that we don't specify a specific GKE cluster with this policy binding. This is because workload identity bindings apply to all Kubernetes service accounts which reside in a matching namespace across all clusters in the target project. This is an important detail to consider when you're thinking about how to manage your GCP resources in your project structure, but keep in mind that the binding will only take effect if the Kubernetes service account is also annotated as described here. Next, we're going to look a little bit into how we have solved load balancing and request routing. So just a quick reminder about our requirements in this case. We want to have a single endpoint and a single subdomain for our application. We need path-based routing to route requests between our front end and our back-end service. Our end user traffic should be secured with HTTPS. And to avoid exposing our cluster ingress to the internet, we would like to restrict access to cluster ingress if possible. It would also be very nice if we could use Kubernetes resources to manage all of our load balancing infrastructure for the application. Let's see in a little bit more detail how we've addressed these requirements in our reference web app. In this diagram, you can see the resource layout for the load balancer used in our reference web application. If you're not familiar with GCLB, this diagram probably looks a little bit intimidating, but we'll break it down over the next few slides and look at each section in more detail. At the heart of our load balancer is what's known as a URL map. And our URL map defines an association between request paths and backend resources. In this case, our URL map includes a default route to a backend bucket associated with the GCS bucket that contains our static application assets. It also includes path-specific routes to multiple backend services, which are each mapped to individual Cloud Run for Anthos services running on our cluster. By default, a custom host header is required to ensure that requests received by the cluster ingress are sent along to the correct service on our cluster. In this case, we're using GCLB to inject these host header values and to make sure that our requests are sent to the appropriate service on the cluster. In the case of the reference application, we've configured our load balancer to terminate SSL. We've used a Google managed SSL certificate for this case. Because our end user traffic always starts at the GCLB endpoint, our cluster ingress doesn't need to be exposed directly to the internet. Traffic to the ingress of the cluster can be restricted to only be allowed from trusted sources, such as GCLB's well-known ingress ranges. This can be achieved through either using a private cluster or, as in the case with our reference application, using firewalls to restrict where that traffic can originate from. When you provision our reference web application with the automation we've included in GitHub, we'll actually automatically apply these ingress traffic rules to restrict access to the cluster. There's a lot of individual resources to provision and manage with a load balancer like this. The config connector, or KCC, provides the ability to manage all of these resources using KRM, and they do this by defining Kubernetes CRDs for each of these GCP resources. In the case of our reference application, we install KCC on the same cluster used to host our backend services. Infrastructure for our application can then be provisioned and managed by creating KCC resources on the same cluster. You can reference and reuse any of the infrastructure configuration that we talk about in this presentation by referencing the KRM in our GitHub repository. You can connect Cloud Run for Anthos to a GCLB load balancer using a standalone network endpoint group, or an NEG. Cloud Run for Anthos uses Istio to manage its request ingress to the cluster. Even when you don't explicitly install Istio, we package a minimal version of it with Cloud Run for Anthos when you install it on the cluster. All requests that are bound for user services on your Cloud Run for Anthos cluster first arrive at what's called the Istio Ingress Gateway service on the cluster, and are then routed from there to the appropriate user service. To connect to GCLB, we are going to create a network endpoint group associated with the ingress gateway on our cluster. To do this, we add a cloud.google.com/neg annotation to the Istio Ingress Gateway Service resource, and this is just a standard Kubernetes service resource. In response, GKE will add the NEG status annotation automatically to that service resource, and this annotation will include the ID and the zone of the associated network endpoint group. We'll now create a backend service to associate with this network endpoint group. We want to bind our GCLB backend service to a specific end user service on the cluster. So we configure the backend service with a custom request header for the host header field of the request. Cloud Run for Anthos uses this host header value to determine where to route the requests once they arrive at the Istio Ingress Gateway service. All of the requests, as a result, forwarded to this backend service will arrive at our desired user service on the cluster. The network endpoint group is then added as a backend to this backend service using its ID and zone that we received from the GKE annotation. In this case, the backend service is associated with foo.example.com, and we can now include this backend service in the URL map of our load balancer so that we can route requests to it. In the examples on the slide, we've showed gcloud commands to provision these resources, but it's also possible to provision these resources using config connector. You can see an example of this if you look at the KRM resources in our GitHub repository. Finally, we're going to cover how we handle end user authentication and authorization for the reference application. As a refresher, we're building an application here for internal use by employees. So it's important that we authenticate each end user that arrives at our application. We would like to use a federated identity provider, and we'd also like to implement email and password authentication as well. We're going to need role-based authorization to allow us to limit access to certain features on the application based on a custom user role assigned to each user. In this case, users can be either workers or managers. Let's take a look at how we've solved authorization and authentication on our reference application. So we've chosen to use Google as our federated identity provider. This allows end users to sign into the application with their Google account. We've also implemented email and password authentication. However, this is mostly to easily enable certain testing scenarios. Covering how this works end to end, when a user authenticates with our application, they receive a JSON web token. And this JSON web token is used by the front end to make API calls to our backend services. When a request arrives at the Istio Ingress Gateway, Istio is configured to validate these tokens with the GCP identity platform and also enforce role-based authorization for various methods and APIs on our backend services. Here you can see an example of the Istio authentication policy created to validate these JSON web tokens against the Google Identity Platform. In this case, it applies to all requests with paths that begin with the /API prefix. We also configure authorization in this case with Istio resources, and you can see an example of that here. In this case, this policy authorizes access to the post method of the inventory transaction API for end users with the role type worker. All of the authentication and authorization resources used in a reference application can be found in our GitHub repository. I'm now going to hand it over to Justin for a demo of how to provision the reference web application in your GCP project.
Now I'm going to give you a quick demo of how easy it is to get the sample up, running, and deployed into your GCP project directly from GitHub. As you can see here, I am on the GitHub repository for the sample application, and here is the README, and this README actually has a step-by-step walkthrough and includes scripts that will get the sample built and deployed into your cluster, which I'm going to show you a little bit of right here. You can see there's a big blue button that says Open in Google Cloud Shell. What this actually does is it clones this repository into your GCP Cloud Shell VM. And from here, you can edit the code and then follow along with the README to deploy it right into your GCP environment. So I've already got this set up ahead of time, but what I am going to do is go ahead and run the included script to kick off Cloud Build and get the application deployed into my environment. I'm going to kick off a make. And as you can see, it's getting started there. And I'm going to hop over here to Cloud Build, and you'll see that that has triggered a Cloud Build. It should be running now. You can see that that build is running from what I kicked off in Cloud Shell there, and it's fetching the source from the latest commit. And now, given that this is going to take a little bit of time to set up, go through all of these steps and set up the infrastructure, I'm going to skip ahead in time to a build that already completed and show you that I've got the backend services for the application running in Cloud Run for Anthos. And you can see that there's a user service and a backend service for different components of the API that the application is calling. Over the last hour, you can see some metrics. Hasn't been a whole lot of utilization because I just spun this up. But you can see the request count, the number of container instances for the backend, etc. And then finally, I can actually just show you the application running live here. I can click the G button to log in. Now I've logged in, and it's going to load the inventory of items. There we go. Perfect. So to sum everything up, Cloud Run for Anthos gives you the best of serverless development patterns in a Kubernetes environment. By integrating with the suite of other GCP services, it's possible to implement an enterprise-ready web application using Cloud Run for Anthos and the rest of the Anthos and GKE ecosystem. And finally, everything we just showed you is open source and available on GitHub for you to try and deploy into your own GCP environment. So on behalf of Adam and everyone here at Google Cloud, we want to thank you for watching our presentation and hope you have a wonderful rest of your day.